Hey guys, my name is Emily and today I'm going to be teaching you about transformations of functions. F of x equals x squared is a basic function. The graph of this function looks like this. It is U-shaped and symmetrical on each side. Now I am going to show you what happens when you add numbers to the equation and you will see the shift right, left, up, or down in the graph. Let's look at the equation f of x equals x minus 3 squared minus 1. I added numbers up to 3 on the graph to make the shifts more easy to see and understand. The graph shown now is the parent function f of x equals x squared. We change the equation to subtract 3 from the x squared and subtract 1 from the end. First, let's look at the shift caused by the 3. As you can see, the parent function is symmetrical about the y-axis and is centered on the point 0, 0. When you add or subtract a number inside the parentheses, like the 3, this indicates the movement horizontally. This is tricky only because the graph moves opposite of what you would think. When you add a number, the graph will shift to the left, while when you subtract a number, the graph will shift to the right. In this example equation, we are subtracting 3 from inside the parentheses, which means the graph will shift 3 units to the right. The center point of the parabola will move from the point 0, 0, where it is now, to the point 3, 0. If the equation said f of x equals x plus 3 squared minus 1, then the shift would be to the left rather than to the right. Now that we know the number inside the parentheses is responsible for the horizontal shift, let's learn about the vertical shift. When a number is subtracted at the end, the graph will shift down. When a number is added, the graph will shift up. It's that simple. Because the example equation says minus 1, the graph will shift down 1 unit on the y-axis. Now we must add the two shifts together to get our new graph. With the horizontal shift 3 units to the right, the center point of the parabola moved from 0, 0 to 3, 0. Now, with the vertical shift 1 unit down, the center point will now lie at 3, negative 1. This is what your new graph should look like. As you can see, the parabola is the same shape and size, but the center point moved over 3 and down 1 unit. Using the parent function as an example, let's look and see what happens when the equation is f of x equals negative x squared. When a negative is added in front of an x squared, the parabola will flip across the axis. The center point will remain the same, but essentially the parabola will go from a smiley face to a frowny face. Your new parabola should look like this. Let's do one more example just to make sure you have the hang of it. For the equation f of x equals negative x plus 2 squared minus 3, there will be 3 shifts in the graph. First, we know that because it has plus 2 inside the parentheses, the graph is going to shift 2 units to the left. Next, when we look at the negative 3, we know that it's also going to shift down 3 units. So it will go from here, to here, to here. Lastly, let's look at the negative out in front. Remember that when there's a negative in front of the x, that means the graph will flip. So it won't be a smiley face, but it will be a frowny face, starting here. This is what your graph should look like. The new graph is in the blue. It has moved 2 units to the left, 3 units down, and has flipped. Thanks for watching, and I hope that you now understand the transformations of functions a little better.